Good morning and good afternoon, everybody. Welcome to our CRWall GPL webinar. My name is Mike Dillon. I'm Vice President Business Development with CRWall. And on behalf of CRWall and Foothills Industrial Products, now a CRWall company, and of course GPL Odorizers, we would like to welcome you to our webinar introducing the GPL 750 Odorizer for challenging odorization applications. And now it's my pleasure to introduce our presenter and subject matter expert, Garrett Cox, Director of Operations with GPL Odorizers based in Lakeland, Colorado. Garrett has worked for Linc Linc Energy Systems GPL Odorizers for 7 years. He specializes in gas measurement, regulation, and odorization. Outside of the office, he enjoys spending time with his 3 dogs and recently new wife, Andrea. We've known and worked with Garrett and his family for many years and can attest to his depth of knowledge and passion for this subject, and we're sure you will learn a lot. Please note we encourage questions and we'll take them real time. Just use the QA feature to input and I will read them aloud for Garrett. And with that, I will turn it over to you, Garrett. Thank you.
Okay, fantastic, Mike. Well, again, appreciate your guys' time here. And as Mike said, I'm with GPL Odorizers here out of Colorado. So again, kind of where we wanted to take this meeting here and really focus our time on is what we've really specialized in the past 6 years that we've owned this odorizer company is taking a real in-depth look at low flow odorization and how do we provide solutions, how do we provide viable solutions, how do we provide robust solutions for a very, what we found to be underserved low flow market here. So again, as Mike said, as questions flow in, obviously feel free to funnel them through Mike and we'll kind of stop and we'll address the questions as they come in here. So and Mike, can you hear me okay with my headphones in here?
You sound good on my side, Garrett.
Okay, fantastic. So just a little bit of a background of who GPL Odorizers is and who Linc Energy is. So just to give you kind of a roadmap here of kind of where, what you're looking at. So Linc Energy Systems is the parent company of GPL Odorizers. So Linc Energy Systems is a distributor out here in Denver. Started out as a Mercury representative for the Rocky Mountain states and have since added over 30 different product lines to our portfolio here. And about 6 years ago, we added what was formerly known as the ZEC and formerly known as the Century product line to our portfolio. So this GPL name does come from the heritage of ZEC and Century. So for those of you that don't know, ZEC Systems was started again 14 plus years ago by a man by the name of Mark ZEC, and he was actually the Z in YZ. And he broke away from the YZ company and started his own endeavor and really focused. And what you're seeing here today is a product of a lot of his knowledge at the beginning. So he really focused on the low flow side of the market and really saw that as an underserved side of the market. So what he brought to the market was what's called a Z9000 odorizer, and that's going to be a drip style odorizer with a variable position needle valve, again for lower to intermittent flow applications. And then about 10 years ago, ZEC Systems was purchased by a company called Century Equipment, which is a sampling company out in Wisconsin. And that's when they brought their expertise in, and they actually continued developing the 9000 and then started it on the 10,000, which is our high pressure injection pump, which we won't be talking about today, but we do have that in our portfolio. So again, just kind of from a culture standpoint, we are really service-based culture. We really want to understand customers' applications and really meet their needs. So we specialize in doing, custom fabrication, custom coating, anything really to fit into different applications. So we're not going to be a cookie cutter odorization system. We really do focus on your challenging applications and really exceeding expectations in that realm. So a couple benefits of our odorization systems here. The first being, and kind of where we are unique in the market, especially for a lot of the lower flow stations that are using older pneumatic style pumps, is we're going to be planet friendly. So our systems, the GPL 750 is going to be a closed loop system. So we're not going to be emitting any natural gas to atmosphere. We're not going to be emitting any mercaptan to atmosphere. Our units are designed as such that if there is a mercaptan smell in the unit, there is an issue, right? So we got a closed loop system, and we're not venting anything to atmosphere, which again helps for the environmental standpoint, helps from just really a public image standpoint where you're not getting all these leak calls. And again, you're not wasting gas as well with the new, like you would in a pneumatic style pump or anything where you're using actuation gas. Another thing that we really focus on, and you'll see this in our 750, is we want to be what we call boringly reliable, and we want to be simple for our customers to operate. We understand that there's a lot of different functions for gas operators who are operating odorizers, right? And they may not even touch an odorizer, for a month, 2 months. And what we want to bring is a unit that can be familiar to a customer when they get in front of it after they've been trained. And we want to basically strip out anything that wasn't necessary for these units. So we basically made it as simple as possible. And as functional as possible. The other thing we were able to introduce and really leverage when we picked up the company.
Garrett, can I interrupt just for a second? We've got just a comment came in from one of the attendees.
Sure.
Asking if she was the only one having audio problems. Is everyone able to hear Garrett okay? If you're not, just ping me on the chat function and let me know. Okay, looks like so far from the response, so far so good. So there's the feedback on that. I apologize for your difficulties. Go ahead, Garrett.
Okay, perfect. So one thing we were able to do as well is we were able to bring in some newer technologies, and really where that shines for us is going to be our controller interface. So we're able to obviously do a touch screen, which you'll see here, which makes it easier for customers to navigate. We're not talking about push buttons, which tend to a few different things. They're very cumbersome to troubleshoot. It's hard to see multiple things at once, and if you don't know which screens you're looking at or which screen is next, it can make it very, very difficult to actually troubleshoot the unit. So we wanted to use the newer technology that is available, whether it be remote capabilities or whether it be our PLC RTU combo for our controller. So again, understanding that when these odorizers go down or when people are working on them, we need to get them up efficiently, and we need to get them up without the frustration from the technician side. So we're going to start out with, again, focusing on this low flow in our experiences and our a lot of solutions that we've been able to provide customers over the past 6 years in these challenging low flow scenarios. So the first is, what do we classify as low flow? I think that probably every company is going to classify it a little bit differently. But where we really see customers, at least in the States here, calling low flow is we're talking about 10 MCF an hour. So 10,000 standard cubic feet an hour at any time. And then a lot of times when we're looking at these stations, they will be much lower than that. So we even see 10 as kind of our high mark for low flow. So we'll see flows as low as 200-300 standard cubic feet, where you've got 2 or 3 customers, and it becomes very, very difficult to navigate these stations and odorize these stations because the flows are so low, but you still need to odorize. Where we're finding these stations, right? You've got your small town border stations, so kind of these outlying areas. If they're tail end systems, we've got natural gas expansion, so maybe we're putting in a new station and trying to bring on customers, but in the intermediary time, maybe we only have just a handful of customers. A big one that we're seeing now more and more, and I know from discussions with the folks at CR Wall is these renewable methane facilities. So you got your wastewater, your landfills, and really, and I know that now there's some hydrogen facilities as well in Canada. So we're seeing a lot of these come online, but what we're seeing, whether it's demand downstream or whether it's just not being able to produce as much as they thought they were going to be able to, we're seeing a lot of those low flow applications. And then the last thing, just kind of specialized process. So if there's any kind of plants or anything that are going to be running low flow when they're down, if you've got grain dryers, if your grain dryers are not drying anything and you're just doing, hot water, you're just doing some stove tops, that's where we're seeing these low flow stations. Obviously with low flow, we're talking about very, very small amounts of odorant needed to odorize appropriately. So that means that if we're adding too much or adding too little, we can make very big changes to the odorization of that gas volume in a very short period of time. So we really need to be as accurate as possible because, again, the number one thing being safety from the odorization perspective. We want to make sure that every single customer is safe, even if it's the last farmer at the end of your tail end system. So again, that's where we see there's a real big need for accuracy in these systems. So what are we seeing as customers using on these sites, right? So a few different systems that we're seeing wick odorizers. I'm sure anybody who's dealt with any of these low flow systems, wick odorizers are really the go-to for a very long time. Just got a small odorant vessel, it's got a wick in it, and you're going to install it right onto the pipeline. The wick is going to draw the liquid up through it and bring the liquid mercaptan right into the flow stream. There's going to be a lot of variance in this from what we've seen. Obviously, temperature has a very big bearing on it. Our gas quality, is it dry, is it wet? If it's dry, it's going to absorb a lot more. If it's got some moisture in it, it's not going to absorb as much. What blend are we using? What's the evaporation rate on it? What's our flow going through the station? So obviously when we've got more flow, the wick is going to want to introduce more odorant. When we've got low flow, it's going to want to introduce less. And you really don't have a lot of control is what we've found. So really when we're talking about these wicks, really the only time that we see these now is just at like single users, at end of the line systems or tapping off of high pressures for a farm or some outlying area. So we're not seeing these as much at town borders or the larger volume low flow stations, but we do still see those.
Hey, Garrett, we've got a question here. Question reads, what kind of measurement input do you use to make this work? And can you inject odorant with no flow input?
Okay, so yeah, so the one for the in terms of measurement, we do have a slide here. So the next couple of slides we will go into that. But one thing when we're saying that can we do it without flow input? Yes, we can. So the coding is such that we can actually set a lot of everybody's probably familiar with putting an odorizer on time. So we're saying, okay, inject at every 10 minutes or inject every 5 minutes. The way that we do it is a little bit different. If we don't have a flow signal at the site, again, we do have some options and different ways to do it, which we'll touch on here in the next couple slides. But we do have what's called a manual gas function if you do not have a flow signal available at the station. And you can basically punch into our PLC and just say, I want to odorize assuming 500 cubic feet. You turn your manual gas on and then the odorizer will odorize assuming whatever gas rate that you've manually entered.
And Garrett, when you say 10 MSCFH, you're talking 10 million standard cubic feet per hour, correct?
10,000.
Another question. Pardon me?
10,000, not so just 10,000 right. Standard cubic feet an hour. Yep.
Thanks. That was a question coming in. Thank you.
Yep. Okay. We cover both of those again. The metering will be here in just a few slides. Okay. So the next one, to kind of take the wick a little bit further, we've got our bypass, and I see a lot of folks in Canada calling these kind of sweep tanks. So really what we're doing here is we've modified essentially what we're doing with the wick. So instead of putting it right in line in the system, we are actually, let me get my pointer here. We are actually taking it, and this was one that was actually being decommissioned just recently here, but we're taking the gas flow in here, through here, we've got an odorant tank, again, full of odorant, and we're just passing that fixed volume of gas across here and then back to the pipeline. So what this allows us to do, and you've got, needle valves here as well, this gives us a little bit more control on what we're doing, right? Instead of just having a wick right in line, we're able to control somewhat what gas is actually passing through this bypass odorizer and what's being introduced back into the line. So again, we're going to have kind of the same kind of limitations to this. Again, environmental, is it hot or cold? What's the odorant doing? What's our gas doing? And then what is our needle valve set point, right? We may go out there in the summer and we know that we need less gas volume through here because our demand is lower downstream. We can set our needle valve, we can close it a little bit on the inlet side. Well, if gas flow picks back up, let's say, this station in particular, around noontime, there's a couple restaurants down the road and the gas flow, probably doubles or triples. Again, we're not talking about a lot of gas flow, but we're talking about double and tripling of flow, which means that when we're setting our needle valve on the inlet, we are now under odorizing versus what we set it in the morning. So again, there's some variability to this, and we're not really able to go proportional to flow. We're able to set it to what we think may work, and give us proper odorization rates downstream, but we can see it fluctuate tremendously here. So the next one, and this is bringing us into the realm of proportional to flow injection and actually being able to measure what we've injected into the system. And you've got your pneumatic pump. So we kind of see varying variety, different varieties of pneumatic pumps out there. So I believe this one is just a Williams pump. We see a lot of, especially in the outlying areas, you'll see a lot of chemical injection pumps that have been altered to inject odorant and basically completely custom from the ground up. So you'd see something like this. There are some other systems out there that are designed, from the pneumatic side for a lower flow applications, and they've got timers and that sort of thing. But really the big thing with these is when we're talking about when we go to the lower flow, right? Even if we have metering on site, pneumatic pumps have limitations, and pumps in general have limitations. We have a pump as well, a high pressure pump, and it has its limitations on the low side. We need to be able to stroke this at a certain interval to keep a prime on the pump and continue to odorize. So what happens when we do that typically is there will be a low flow cutoff, and we'll say, well, if it hits a low flow cutoff, we just want it to inject every 5 minutes, right? If it's injecting every 5 minutes and that flow is fluctuating, we are going to get, varying odorization rates downstream when we're doing this. So that's where this differential pressure style, the 750, which we'll touch on here in a couple slides, really shines, because we don't have to keep that prime on a pump. So some challenges and some solutions that we've been able to offer customers, right? So our first challenge is, as that question that came in, is metering, right? What are we using for our meter? Well, what we've found is, for the most part, there's two scenarios. Either, the first scenario is we have metering out there, and that meter is typically, either we're taking a rotary meter, maybe the rotary meter's got a pulsomatic on it, maybe it's got some sort of electronic index on it, maybe it has a corrector on it, but at the end of the day, what we're getting out of that rotary meter is going to be a pulse, right? So, and if we're going off a corrector, it's going to be in a batch, right? The corrector is correcting for pressure, correcting for temperature. So if you've got any pressure that's higher than 7 inches, you're going to, as soon as you make a full revolution on that corrector, you're going to send out a batch of pulses from a corrected volume perspective. And what happens when we send out these batch-based pulses is we're not getting a true feel for what the flow actually is in the pipeline, right? So for example, we've got a customer in Illinois, and they're at about 300 pounds, and they've got some other stuff too. The flow is so low that they basically they only complete one revolution on their corrector in an hour, and then we'll get 100 pulses corrected, right? What we're finding with typical coding is the code tries to take those pulses it says, okay, we've got 100 pulses over a certain amount of time, and then it does math and then tries to spit out a flow rate. And then the odorizer uses that inferred flow rate to try to odorize. What happens when it does that is we're missing what's actually happening and what's actually going on in the pipeline, right? Because the flow could be fluctuating up and down. We don't know what's happening in that hour. So a couple of things that we've done for a solution to that, we've got a custom code, and this is something that our engineers worked very, very hard on. And we were able to, at the end of the day, get a test at 300 standard cubic feet an hour. So we're talking about, nothing more than, I think 100 houses or so during summertime, and be able to actually meet an injection rate of 0.8 right on the nose. But the way that we're doing this is, instead of trying to infer a flow rate from both batch-based pulses or pulses that have latency on them, we are actually just purely odorizing off of whatever volume that we're getting in. So for example, easiest example to use, if we've got 100 cubic feet, we send a pulse back to our unit that says, okay, we need a drop of odorant. 100 cubic feet, we need a drop of odorant. What this allows us to do is actually go right off of that pure volume from the corrector or from the rotary meter to actually odorize appropriately. So that's... Yep.
Does the thermal meter have CSA approvals?
So right now, and then so switching gears, so the thermal mass meter, so this is going to be our second case. If A, there isn't metering out there, or B, we have a place that we can put what's called a thermal mass flow meter from Sage, that is our actual preferred flow signal, because we can get a 4 to 20 off of that meter. And right now, I know they're going for CSA approval, and I believe we should expect that by the end of the year here for Class 1 Division 1.
Yes, it has UL, and that was my understanding, has UL and CSA submitted.
Yep, exactly. And these really, from a low flow perspective, where we're getting our biggest success stories is when we're using these thermal mass flow meters and we're installing them correctly onto the line, because the turn down for these meters matches the turn down for the unit. So we're seeing a lot of success when we're putting these thermal mass flow meters. And if you're not familiar with thermal mass technology, the way that these would be installed, you just have a 3/4 inch valve that would the probe would go into, and you've got your gas flow. You want to put the meter right in the center of the pipe, and all we're doing is we're just measuring the cooling effect of the molecular impact of the gas. And so since we're measuring the molecules of the gas, we do not need pressure and we do not need temperature correction, so that this unit can stand alone in a pipeline and give you corrected 4 to 20 signal to the odorizer. So the person that asked the question on the metering, if you could, did that answer your question fully? I'm not sure if it'll come in on the Q&A here quick enough or not, but are there any other questions on the metering?
Not at this time.
Okay, perfect. So move forward here. So another challenge with these stations is the intermittent flow. The varying flow is as well, but I think the intermittent is really the biggest issue. So whether you've got processes where there's enough pipe and low enough flow where you're actually just packing the line, and you'll have times where the pipeline just isn't flowing at all. Whether you've got a process, and this unit here is actually a wastewater facility, which is close to our office here, about an hour outside of our office, where this is actually running to a filling station for trash trucks. But the process behind it, and this is a wastewater plant, so you've got a lot of different processes behind it, compressors, scrubbing. There's a lot of moving parts. So what we're finding, again, from the renewable methane side, is there's a lot of downtime. So this unit, I think when it started up, the downtime was probably 50%. So it's 50% on, 50% off. And when this happens, if you were using a pneumatic pump, right, you have two choices. You have one, you can try to go off of proportional to flow, and then when the flow, when the flow is running, it'll pick up and it'll odorize. When the flow stops, your pump is going to shut off. Depending on how long it's shut off, it's going to lock up the hydraulics. And again, that's just the nature of pumps, whether it's ours or anybody else's. With this system, you're actually able to, because we are differential pressure with this 750 here, and this is one of our skids here, and we'll go into that a little bit later, but because we're using differential pressure for our injection, we can basically sit dormant indefinitely. As long as we have pressure, our system will be self-priming. So this is where we're seeing a lot of our success with these on-off process, is we're able to, this unit, for example, we were able to sit a week, just sit there and do nothing, flow kicked back up, turned right back on. Because we've got our differential pressure, we're able to drop right into the pipeline and provide the customer that odorization without any intervention. Another challenge that we found, and this is becoming more and more of an issue as we move forward with our customer base here, is we're seeing a lot of aging custom solutions, and we're seeing their inventors go along with them, right? So a lot of these low flow stations, they're outlying areas. So either due to just pure necessity, or whether they took it upon themselves. We're seeing a lot of these custom systems, and then whoever invented them will retire, and nobody will know how to operate these systems. So if you look here, that this was one that we've recently taken out. You've got your hydraulic pump here, so similar to what we saw in a few pictures over, or a few slides beforehand here. This is all controlled off of an RTU, and the only way to control this is actually through the coding software for the RTU. So again, very, very complex, and it works very well when the guy who invented it is operating it. But once he retires, without any knowledge, without any manuals, which we're finding a lot, it's very, very hard to keep these systems operating. And even if we do, to make sure that they're accurate, there's so many nuances that we're seeing with these custom solutions. It's hard to ensure that they are actually operating appropriately. So what we've been able to do, and from a limited resource standpoint too, we understand that customers aren't able to provide as many resources to the outlying areas. So those guys are typically doing a lot of different operations daily. So what we wanted to do is we want to do a user-friendly interface. We only have one moving part in this system. And really what we're talking about here when we're troubleshooting with customers, do you have differential pressure on your tank? Is your odorizer dripping? Is it registering the drops? Are the drops falling quick enough to meet demand? That's pretty much it. So typically when we're talking about a service call, we're talking about no more than 15, 20 minutes here, which is good for our customers who have a lot of other things to do, because they've got a lot of other job functions in these outlying areas. So now switching gears to the actual system here. This is going to be our 750 odorizer. So over here, you've got your mechanical cabinet, and then over here, you've got your electronics cabinet. It's going to be a 2-box system. Because we are a drip style system, we will need to be above the pipeline enough to where we can get a 45-degree angle to drip into the pipeline. So design considerations, again, we wanted to make it simple. We wanted to make it user-friendly. We wanted to be able to log what we are doing, what we're injecting, to actually prove to regulatory agencies, to supervisors, to whoever needs to see what we've injected and what has flowed through our station. We wanted to be able to track that and make it non-volatile so we can move it around very easily. Wanted to take a look at really just making it more cost effective to run the system. I do see we've got a question here, so I'll stop at this slide here. But we wanted to really use quality components from manufacturers that we trust. So instead of machining our own parts, we do now have, we use a lot of components from trusted partners.
So Garrett, can I interrupt? I've got a couple of questions for you here.
Okay. Yep.
Firstly, can the system be wall mounted? Was one?
Okay, yep, so the system can be wall mounted. So Again, we can put them on a post, and I've got a couple of pictures of installation here at the end, but yes, it can be mounted on a wall, it can be mounted on a stand, it can be mounted on a post. It can actually be mounted to the pipeline with some sort of a saddle as well. As long as we can get, with that gravity drip feed, we want to be able to make sure that we can get that 45-degree angle to the pipeline. So yes, it can be wall mounted.
Okay. And what is the minimum differential to make the system operate?
So the minimum differential is going to be 20 pounds. So if you have two cases, so if we're talking about a pressure cut, you can take pressure from the upstream side and regulate it down. So we'll need 20 pounds over pipeline pressure in the bulk tank, and then we're going to cut it on the regulator. But the minimum differential is going to be 20 pounds on the tank to the pipeline. So we can either do that from an upstream cut, or we can actually use nitrogen to pressurize the tank as well. Perfect. So the last two things here, continuous drip mode. Nobody's familiar with the 9, so that's not going to be of any value here, but we basically learned lessons from our existing unit, the 9000, and eliminated a function that became problematic. And then the big thing we wanted to focus on was extreme low flows, so less than 1,000 standard cubic feet an hour to be able to odorize effectively. So just a PNID of kind of what we're talking about here. I'll just do a broad brush as we're going through. We'll get more in depth here, but as we talked about, because it is differential pressure, we are going to need 15 to 20 pounds above our pipeline pressure. Our PNID here shows nitrogen giving us that differential. In other cases, we can just take it straight off of the pipeline if we've got a high pressure cut. So got your supply tank here. Obviously, you've got all your valving to fill it. Add your blanket gas coming in here. You've got a filter. This is going up to our regulator. Our regulator is going to be sensed from the pipeline, which allows us to just give us a fixed set point on the reg, and we're going to set that 5 to 10 pounds over pipeline. So you've got 15 to 20 on your tank, and then 5 to 10 inside the cabinet. And again, this is all liquid. And then you've got your sense line, which is going to load the dome of this regulator. So as pipeline pressure fluctuates, you're going to keep your 5 to 10 pound set point on your spring force for your regulator. So what this allows us to do now is come up to here. You've got your solenoid valve. We can everything downstream of this regulator, because the regulator is keeping our pressure constant. We're able to go fixed here. So we've got a solenoid valve, normally closed for safety, right? If the power goes down, it is going to fail closed. Coming up here, we've got our metering valve, which is going to control the rate at which our drops fall. So it's not going to change the volume of our drops. The drop is always going to be 0.01 cc's, but it is going to change how quickly they fall. So we open the metering valve, drops are going to fall faster. We close the metering valve, drops are going to fall slower. Here we've just got a 1/4 inch to 1/16 inch reducer, and that's that loop that you saw in the picture. And we've got another one here. Dropping here through our odorant drip chamber, which has an optical array, which basically sends one transmit here and then one receive in a horizontal, and it's a visible red beam. So as the drops are falling, we're seeing a drop in signal strength across this beam, and that's being interpreted by what's called our optical comparator. And this is really kind of the special sauce of our unit. This has been used almost 20 years to count these drops. And then that's being fed back to our controller, which is again controlling our flow. It's not controlling our flow, but it's reading our flow from our flow transmitter. So whether that be a rotary meter, thermal mass meter, RTU, and then it's also controlling the opening and closing of our solenoid. Give just a little bit more of a visual on what we're talking about here. Again, you've got your odorant tank 15 to 20 pounds above pipeline. You've got your blanket gas in here to achieve that. Got your green line here, which is going to be our odorant running through our filter, through an isolation valve, just a 1/4 turn ball valve, coming up through our regulator to our normally closed solenoid, through the needle valve, through this tube, down into the drip chamber, again, where these drips are getting counted. And that's all getting interpreted back to our PLC. So we do offer the explosion-proof option as well, which I know is important in Canada. Coming down to here, this is what's called our sonic muffler, and all this really is if we do have pipelines where you have high velocities, this will just dampen any kind of any kind of noise, any kind of turbulence, so that we're not breaking the drop at the sight glass. On the low flow perspective, it allows for the odorant to pass through here and actually increase the surface area. It's basically just a stainless steel tube with stainless steel wool in it. And as the drop hits that wool, it's going to increase the surface area and increase our absorption. Coming into the pipeline, we just have an isolation valve where you can lock it here, and then you just have a blowdown valve where we can perform maintenance. So if you ever needed to perform maintenance, you would lock this unit off here. You would insert a nitrogen source to get higher pressure than your tank. You would open up your solenoid and you can blow all the odorant back to the tank, close this valve off, and do any kind of maintenance that you need to do.
Garrett, thank you. We've got another question here. Are there alarms if I have a flow with no drop showing up?
Yes, so that's actually perfect segue here. So there are alarms. So if you look at our PLC here, it's got full alarm capability. So you've got different alarm set points. So you've got low, low, you've got low, you've got high, high, and then you do have a special code for no odorant. So yes, if the odorant rate drops out of program parameters, it will alarm. And it will send out a digital output pulse for an alarm as well. So it does have full alarm handling capabilities, and that can be set as stringent or as loose as deemed necessary by the customer. So switching gears to components, again, this is our 7-inch style controller. We do have a 4-inch if we were going to do the explosion-proof option, but they are both going to be touchscreen, and they're both going to be all in one. So you've got your interface here. Again, you've got your touchscreen LCD display, and then you have all your I/O in the back. So your gas flow coming in, your pulses coming in from your drip counter, and your alarms out are on this side, and your digital outs are on this side. So again, very capable.
What's the low temp rating for this system?
So the low temp rating for the PLC is going to be negative 40C, and that does have a CSA cert on it. The mechanicals cabinet, and again, we would have to look at. I know that negative 40 is the spec in Canada, but we do offer heaters to meet that spec. So this unit standalone with a heater, again, the heater adds about 0.5 amp to the current draw, but this unit will withstand negative 40C and still give you all functionality with the heated display.
And what is the power source for the PLC?
So the power source, and it depending on what customers are going to use, right? So you've got the most common that we see, especially if it's going to be really cold and you're going to be running a heater, would be 120 volts coming in to the heater, and then this unit itself is going to take 24 volts DC. So you need some sort of a converter. That's the typical way if you do have power at the station. We've taken a look at other options as well. If you're doing outlying areas, you could do something like a thermoelectric generator with the unit in a building with a catalytic heater to provide heat. And then if you do have something else that can provide heat, we can also do solar. So if you're going to do a building and you had a catalytic heater to keep the temperature in the building, and I believe the spec that we're looking for would be negative 14 C. If we can keep the building above negative 14 C, we can use solar, because that means we won't have the heater here and we won't need a heater in the cabinet that's going to be 120.
Thank you.
And again, a couple main points on this controller. In the top right here, you have just a 16 gigabyte micro SD card, and that's where all your alarms and your usage logs are going to get stored. So you're able to pull those logs, and I've got some pictures at the end here, and that they just download right into an Excel spreadsheet, and then you can just put the card back in. So you don't need any software to get into this unit. This is all interface right with your touch screen there, and then any logs you're going to have in your little micro SD, which is in the side of the unit there.
There's another question coming in here as well. Do you have a fully enclosed secondary containment package?
Yes, so we do have secondary containment packages. From a fully enclosed, we can offer something like that, but our standard is just going to have a roof on it if we're talking about the palletized unit. And we do have a picture at the end here, but that is our standard. With any tank that goes out the door, we'll have secondary containment. Obviously, we need 110% containment of the liquid. And for our smaller stuff, for the 60s and 120 gallons, we do stainless steel containment. And then for our larger containments, we're going to do galvanized steel. And again, we got some pictures at the end that'll show the kind of what capabilities and what we've done for customers here. So just going through our components again, you've got your pressure regulator here. This is a liquid regulator designed specifically for liquid. All the soft goods are PEEK, Teflon, or 316 stainless steel, so we don't need to worry about corrosion from the odorant. And then you've got your sense line here, which is again going to allow that pipeline pressure to actually load our regulator. So when we're adjusting this reg to our 5 to 10 pounds above pipeline, as pipeline pressure fluctuates, we'll keep that 5 to 10 pounds of spring force on the unit. So that allows everything here from here up to be fixed. So you've got your normally closed solenoid here. It's got a little override knob, which we'll go over here in a bit. Got your metering valve, which again is going to control the speed of our drops for each batch. And then you've got your 16th inch tube that's coming down into our drip chamber. And then you've got your one transmit, one receive from this optical comparator that is looking for a break in that beam to count drops and send them over to the controller. So the way that this unit odorizes is on a batch function. So when a batch of odorant is called for, so when odorant needs to be delivered to the system, the controller is going to send a signal over to the solenoid, telling the solenoid to turn on. Odorant is going to move through here, and it's going to drop into the pipeline. Once the desired amount of drops have fallen into the pipeline, the solenoid is going to close, and then the unit is going to wait for more gas to flow. So that's how we're able to get those lower flow stations, is we're actually able to produce one single 0.01 cc drop at a time if necessary. So we're able to go that low on the injection, and then we're actually able to, from a turn down perspective, go all the way up to 750,000 standard cubic feet an hour. So on one set point, because the solenoid is so quick acting, we can produce a single drop, and we can say, let's say we're doing 100 standard cubic feet an hour. And on the same set point, as long as our needle valve is set appropriately, we can meet the entire range of the unit up to 750,000. So
Garrett, it's my understanding the 750 can be tuned to as high as 1.2 million. Is that right?
Yep, that's correct. So if you did have an application that was low enough pressure, again, because we are differential pressure, we're limited to our pressure rating on our tank. So the standard rating is going to be ASME 250. So which typically means we don't tell customers to go any higher than 200 pounds on the injection pressure. But if you do have a higher flow station that is lower pressure, we do offer, and really the only thing it changes is this changes from a 16th to an 1/8 inch strip tube, and we do offer the range ability to go up to 1.2 million with the same turn down to be able to just produce one single drop. That's a blank slide. Okay, there we go. So big thing, we're talking about 5 components, including the controller. So there's no unnecessary components in this system. Everything that's in there has a, its specific function and really is designed to be robust and easy to troubleshoot. So we find that any technician that looks at this system and we're presenting it, they seem to not believe that the presentation is over, that there's just that little to the system. So again, simplicity, make it easy to troubleshoot. We only have those 5 components in the system. So for the person here that asked about kind of what an installation looks like, what a typical installation would look like. So again, you've got your 2 cabinet system. So if we wanted to put it on a post, we can do front to back. Here's our tank here. One's in Indiana. Here's another one in Indiana. So kind of a wall mount style. You've got side by side. And here's our injection line here to the pipeline. We can move them further away. We can go 100 feet if you wanted to between electrical and mechanical. We typically tell customers just to be 25, just because if you're working on it by yourself, running back and forth can become cumbersome. But over here, you've got your electronics enclosure. We've got our power supply here. Over here, we've got our mechanicals that's dropping straight down into the pipeline that's underground. And then you've got your larger tank. So from a containment perspective, this is going to be one that's obviously not fully enclosed, but we do have 110% containment, and that's going to be 250 gallons. This one is a 500 gallon. So again, picture of our containment. You've got your mechanical enclosure out here, and then you've got your electronics enclosure in the building. So that if you look here, you've got your solar panel, and they did want the heated display for this one. So their solar panel is larger for this application, but they did put the electronics in the building and the mechanicals outside. So from a security perspective, and if we're talking about Class 1 Division 1, it only has one access level, but if you were to go with the larger screen, you would just need a larger explosion-proof enclosure. We do offer 6 customizable access levels for different technicians, supervisors, so people can just see and change what they need to see. From a remote communication standpoint, and any modem that can be set up as a pass-through modem and can interface with an IP device, we can use to interface with this unit over the air. Again, we don't need any special software. We just need a modem, an antenna. We need a static IP address, and I would suggest, obviously, and obviously up in Canada, I know you guys are very good with the cybersecurity, a VPN, and then you just need that device with internet connectivity, and you're able to actually log into your unit using that modem as a pass-through, and all you need to do is use a web page to actually access the unit. So another question here.
Yes, so the question is, can I interface the controller to an RTU for remote monitoring?
So yes, so you can interface it to an RTU. So there's a couple ways you can do it. You can do standalone remote, right? So you can just run the modem to the unit, and you can interface through a web page over the internet. Or if you want to interface it with an RTU, we do offer Modbus. So you can do TCP over IP. We can do RS-485, and we can do RS-232. And it is going to just be a slave, so we would need a master from the RTU side. But yes, we can interface with an RTU.
Right, and so Garrett, that Modbus is resident on board the PLC right out of the box, right? Yep,
yes, it is. And if there's any kind of special configurations that need to be done, if they're customers using ASCII or they're using a different baud rate, we can change that as well for the customer. But yes, that is all on board the unit. That does come standard with Modbus capability.
Thanks.
And going back to the remote communication, one other thing you can do if you did have a modem, because we're just using basically the controller as the host for a micro SD card, we can use file transfer protocol to actually pull usage and alarm logs from the unit if you did have that functionality from a remote perspective. Usage and alarm logs, this is what we can produce. And again, one thing that we find is unique, especially on the low flow side, is we can actually produce these logs for customers on an hourly basis, on a monthly basis, which keeps them compliant, and it really ensures that everybody is safe. So if you're looking at this one here, our hour gas volume, is 3,000 up to 5,000 here. But every hour we're doing our volume, we're doing our usage. So we're able to track that and be able to provide that to any kind of regulatory agencies or supervisors that need that information. Again, going to be stored in that micro SD card right on the controller. Going to be non-volatile CSV files, which go right into Excel spreadsheets. And you do have your hourly, which is going to be more cumbersome, but it allows you to really drill down if something, God forbid, something were to happen at some point, you can go the hourly route, or you can just do monthly, just from a compliance standpoint.
Garrett, does the RTO have the capability to monitor odorant tank level?
So it does. The only problem that we've found with it is because we're typically using 60 or 120 gallon tanks. We haven't found anything that was extremely reliable from a actual gauge output standpoint. So, we've had customers that'll use kind of like radar gauges that weren't actually calibrated before the odorant was filled. And then so you're never actually going to get an actual reading from that. From the larger tanks, if we can get a 2-inch port in a tank, we can do an actual digital float gauge, which will provide a 4 to 20 out. So the unit itself has capabilities. It's just figuring out the right piece of equipment to actually send out what the tank level is. But it does have
so even a dry contact from a low level output then.
So the dry contact would be a little bit different. We don't have that on board, but if you did have some sort of a switch closure, we can again pivot and just make a custom code to meet that application. That kind of goes back to our willingness to kind of meet different applications, and that would be something like some sort of a limit switch where you're switching that close, the unit's recognizing it. It's got the IO on board. It would just need to be coded in.
Sure. So another question would be, can we do a daily download of hourly data through a system like Autosol? I'm sure you're probably familiar with Autosol, Garrett.
So at this point, we haven't taken a look at that. We haven't had any customers that have requested that, but we would definitely be open to taking a look at doing that. And again, with our PLC, there are a lot of different things that we haven't even scratched the surface on it in terms of what it can do. So I think as long as we were able to take a look at it, I think we could make that happen, just depending on what the requirements were.
Sure.
But at the time, no.
We've worked a great deal with Autosol, numerous systems. We could certainly work with the team to do a quick test, proof of concept. So knowing Absolutely. The capabilities of Autosol, I suggest is highly likely.
Okay, fantastic. Yep, and again, that goes back to our willingness to do the custom applications and kind of meet the customer requirements instead of trying to have them meet ours. I think did I see another question come in?
No.
Okay.
So just a quick time check. You're at about 8 minutes. So.
Okay, perfect. We got a few more slides here. So the next one is going to be our manual mode. So this is something that was unique with our 9000, and we wanted to carry over to our 750 because it is something that's extremely helpful if you're in a pinch. So if for some reason you had a power failure or you had a component failure, let's say your controller gets struck by lightning or something happens, we do have an override knob on our solenoid. Again, you've got closed and you've got open. You've got this little arrow here, and it's just a flathead screwdriver, and you turn it 180 degrees. You can open up your solenoid, and then you can put it in a manual drip mode. So you're still odorizing. Again, we've taken the proportional to flow characteristic out of there because we took the control away from it, but you're able to actually dial in your drip if you did need to odorize. And you would use your differential pressure on your regulator, and then you would use your needle valve to control that drip in a continuous drip function. And then we've got our little calculator here that we can provide you, which basically you put in your flow here, you put your ratio here of what you want pounds per million cubic foot of gas, you put your odorant density, 0.01 cc's. This doesn't change, this is fixed. And then it'll tell you how many time between injections. So here we need to drop every 5 seconds to odorize, assuming a fixed flow rate of 25 MCF or 25,000 standard cubic feet an hour. So going to our other products and kind of showcasing some of our custom projects that we've done for customers. So there was a question here about if we did fully contained containment systems. So here is a system that's actually got fully enclosed with a roof. That's all aluminum frame. You've got a big double door so you can access all of your valves here. This is I believe a 500 gallon, and then you've got your 110% containment down there. This unit is typically what we'll see, what we're seeing a lot at our wastewater facilities, at our renewable methane applications, because there's a lot of other components to it. is actually just doing our turnkey skid package. So you've got your stainless steel containment. This is going to be a 60-gallon. This is an aluminum pallet, so you can move it with a forklift very, very easily. You've got your roof here. The roof is removable if you ever needed to get to the tank. You've got all your pressure control here. Your units are mounted here. And when the unit ships to you, it would be all tubed. So only thing that needs to happen is power needs to get run, signals need to get run. We need to get a gas source in, and then we need to go to the pipeline. So it's very, very easy installation. Right. So we got a question here.
Yeah. So how often does a nitrogen tank need to be filled or replaced?
So that's going to really depend on what the flow is. Right, and we can provide calculations, but typically for these low flow stations, if you're using a 60-gallon tank, you're really talking about the nitrogen bottle. As long as you don't have any leaks, the nitrogen bottle lasting you years and years. So it's really going to just depend on fluid usage, which is going to be displacement for that nitrogen. But because we're talking about the lower flow systems and we're not actually actuating the mechanical side of things with the gas, we're using very minimal nitrogen.
Okay, and could we alarm on the liquid level in the containment?
Again, if you want, we do have I/O available on the controller for a digital in. So if there was some sort of a sensor, liquid level sensor on the containment, we can definitely run that into the controller and code that in, no problem.
Thanks.
And obviously, if you do get water in your containment, you've got your drain plug here, but that's why we've got the roof. Obviously, we understand that it blows sideways, especially up in Canada. That's where we would go fully enclosed and take a look at a custom solution there. So some other products that we've done. So this is a customer that we've been doing a custom explosion-proof application for. So you've got your controls down here, you've got your mechanicals down here. And the reason that they're kind of offset like this is I believe this is a 5x5 building, or may even be a 4x4. So going back to being able to meet our customers' needs, this was really necessary because this was a customer standard. So this is their standard design now. It's very, very compact. It's on a stand, very easy to install. So that there's not much, when they get the unit, it's already run conduit, everything is ready to go. They just have to hook signals, hook up odorant inlet, and then hook it up to the pipeline. This unit is something new for us for 2020. So that this is actually a mobile pickling unit. So this is a 3-part design. So you've got your base here. Obviously, you've got your nitrogen for your blanket gas. You've got your DOT odorant tank here. And then this unit is bottom here, tray will be our containment. Then you have your mast here, and then you have your odorizer. So you've got mechanicals here, electrical in the back, and then this is adjustable. So whether we're using this for pickling jobs, or whether we're using this for temporary odorization emergencies, this is very, very light and very, very easy to transport, because we're able to take this base apart. So you only then take your tank off, take your nitrogen off. You've got your base, you've got your mast, and then you have these the units on either side of that post.
So we had another question, and the question is, how much is a typical unit? And Garrett, just for guidance in the Canadian marketplace, guys, you're for a totally self-contained unit, 65-gallon CRN tank, that skid-mounted design we were looking at earlier. You're with remote power. You're certainly you're sub 100K turnkey. So just for guidance, I'd encourage you to drop an email to myself or any of the CRL Foothills team, and we'll certainly walk you through your application. But they're very, very economical for these types of applications.
Yep, exactly. And again, that with being able to provide that accuracy, and what we're seeing with customers as well is that the maintenance parts are going to be very, very minimal, right? So our really one maintenance part that we're talking about is going to be a solenoid, which I'm not sure Canadian what that's going to be. So it's about $800 to $900 US dollars for a solenoid, and that solenoid needs to be replaced every 1,000,000 cycles. So just to give everybody an idea of what that looks like, we have a unit, our flagship unit that we put in Tennessee 6 years ago. We have not replaced the solenoid in it. I think it's about 400,000 or 500,000 cycles, and the unit has just sat and run since we installed it. So again, we're not talking about very, very maintenance heavy, unless you get some sort of an electrical event and have to change out the controller. But really, from the meat of the maintenance side, the solenoid is going to be very, very robust, and we're just now starting to get orders for replacement solenoids after selling these units for 6 years plus.
Garrett, thank you. I want to thank you. It's we're at time here. Is there anything that any last minute questions? If there is, guys, I encourage you to email Sierra Wall Foothills team. We're going to be sending out a link with a recording for the presentation you can share with your colleagues, and look, we're here to support you guys, so let us know how we can help. I want to thank all of you for attending. I hope this was valuable, time well spent, and again, thank you, and have a great rest of your day. And Garrett, thanks.
Appreciate it. Thank you.